Next property, number 5, is differentiation in Z domain. That means if I multiply x of n with variable n, so if I take n x of n, then the corresponding Z transform will simply be minus Z d by dz of x of z. So how will you find the corresponding Z transform? All you have to do is differentiate the original Z transform and multiply it by minus Z. This will be the Z transform of n into x of n. So if you know Z transform of x of n, you can find out Z transform of n x of n. And because we are differentiating the Z transform, the property is called differentiation in Z domain. Please note that there are otherwise lots of properties associated with Z transform. We are just looking at some important properties which we may come across. The next property will be of time convolution. In time convolution, we again consider two signals x1 and x2n and we convolve them. So if you convolve the two signals x1n and x2n, then the corresponding Z transform will be product of the individual Z transform. So x1z into x2z, the whole thing will be the Z transform, two convolved signals. And see, this is also one very important property. We all know that finding convolution between two signals could be very difficult, but you can see finding the Z transform of the convoluted signals is simply multiplying the two Z transforms. So for this one reason and other couple of other reasons also, we always prefer to do the analysis in Z domain. The analysis in Z domain is very much simplified. And one last property that we will discuss is called initial and final value theorems. Initial and final value theorems state that if I want to find the initial value of the signal, that means x of 0, then I have to do is find the limit of x of z as z tends to infinity. So if I apply this limit on x of z, then I'll get one value, and that value will be nothing but initial value x of 0. And final value theorem says that x of infinity can be obtained by applying another limit z tends to 1, z minus 1 into x of z. So if I apply this limit on x of z multiplied with z minus 1, then it will give me the final value. So initial and final value theorems can also be obtained from the Z domain representation. We may not have to solve the time domain representation, but there is one condition which we have to remember. These two theorems should be applied only when x of n is causal. So these theorems are used only when x of n is a causal signal. If x of n is not causal signal, then I can't use the initial value theorem, because in that case the initial value will not start from n equal to 0. A causal signal is the one which is 0 for n less than 0, and hence its first non-zero value will start from n equal to 0. So x of 0 will be the very first value, non-zero value I would say, in the causal signal, and hence only in that case we can talk about this initial and final value theorems. So this was a brief overview of various properties. We may use some of these properties in our discussion, so you guys will have to remember it. Let us look at few examples now where we find the Z transform and apply some of these properties.